Okay, so now we get to example 4. 18, what's the square root of 18? Is 18 in my perfect squares column? No, it's between 16 and 25. We know the square root of 16 is 4. We know the square root of 25 is 5. So it's not a nice number. It's not a whole number there. So 18, how do we deal with that? So with that 18 now, we want to not plug this into our calculator. Most of your calculators are going to give you a decimal. We don't want a decimal. I want to simplify this down as if I was simplifying down a fraction to lowest terms. 4/8, we simplify it down to half to lowest terms. We're kind of doing the same thing here with the radical. And the way we do this is a couple different ways. If you've seen it last year, there's kind of two big different ways. I see students coming in knowing it. If you haven't seen it, the way I'm going to approach it is by doing prime factorization. And what I mean by prime factorization is get your factor tree going. Take that 18, and we all know how to do factor trees. Something that gives you 18, 2 and 9, 3 and 6, anything that's going to work fine for you, because at the end we'll get the same prime factorization. 18, 2 and 9, 2 is prime. 9 is not prime. If you're not prime, you are what? Composite. 9 is 3 and 3. And as those primes appear in my tree, I like to circle them so I don't lose them. And once I get down to all primes, I'm going to rewrite 18 as a product of primes. Now, because this is a square root means 2. I'm looking for some number times itself here to make a perfect square. I'm looking for sets of the same number, pairs of the same number. In this case, I got a set of 3s, a pair of 3s. Well, pairs make perfect squares. 3 times 3 is 9, and what's the square root of 9? A 3 comes out front then. 2 does not make a perfect square. There's not another 2 to make a pair with it. So that 2 stays underneath, and the square root of 18 simplifies down to 3 root 2. So that's what we're going to be doing here today. Now that's one example down that I don't expect you haven't mastered yet. Let's do another example. Example 5, same deal. 48 is not perfect. That's where I'm focusing on. So we're going to take that 48 off to the side, do your prime factorization of 48. So I'm going to start off with what? Probably most people would say 6 and 8, 2 and 24 is fine, whatever, 3 and 16, 2 and 3, 2 and 4, 2 and 2. Okay, I'm going to rewrite the 48, its prime factorization as what? Looks like 4 2s and a 3. Pairs make perfect squares. I'm looking for pairs of the same number, which in this case I get 2 pairs. For every pair, again, 1 comes out because each pair makes a perfect square. 2 times 2 is 4, and the square root of 4 is 2. 2 times 2 is 4, the square root of 4 is 2. That 3 cannot make a pair, so it's not perfect. It stays underneath. Now that 10 that was out front, anything that you pull out front is going to get multiplied together. So we have 10 times 2 times 2. Let's clean this up. That gives me what? 40. Square root of 3. So 40 root 3 is its simplified answer. 60. Probably the obvious for 60 is 6 and 10. 2 and 3. 10 is 2 and 5. You'll get quick at it, okay? Usually by the beginning of day 2, everybody's usually pretty good with these first few things of simplifying radicals. Trust me, you're gonna get plenty of practice this year. So I'm gonna rewrite 60 as what? 2, 2, 3, and 5. And pairs, okay? Every pair, for each pair, 1 number comes out. So 2 times 2 is 4, and the square root of 4 is 2. I had a negative 6 out there. 3 and 5. Well, it's not the same numbers, so they do not make a pair, so they stay underneath. Now clean that up. Multiply everything back together. Negative 6 times 2 is what? Negative 12. And 3 times 5 is 15. And that's as far as we can go. That is now simplified. I'm going to pause at